Welcome everyone.
Okay.
Happy Saturday. We are live, Ravi, and we are live doing our first episode of this weekly series for machine learning for .NET developers. It's super exciting to do this. We're doing this with our peer here, Ravi, who's calling in from India. Ravi, do you want to say hi?
Hey, hello everyone. Welcome to this weekly series. We are starting ML.NET for developers, and it would be for absolute beginners. Let me give some background about me and this group. I'm from this NCR Cloud and Code Techies Meetup group. It is in Delhi. And we basically earlier we used to organize sessions on .NET related topic like Xamarin, Blazor, and all the things related to .NET and technology development. And I met Alex on Twitter, and from there I came to know that he is interested in sharing his knowledge about ML.NET. And since I was also interested in learning ML.NET from beginning, I thought that why not we should go do a streaming session on both of our channels, and we can do a weekly series so that everyone can catch up whatever we have done in first week, and then like in a week they can catch up whatever we have done, and we can learn about ML.NET from very beginning. Like someone who is just a .NET developer and doesn't know anything about ML.NET, probably they can start with that. That's my idea, and Alex is also on board with it. Hopefully, you will learn something new from here.
Yeah, it's gonna be really awesome.
Alex, back to you.
Yeah, I'm super excited. So as Ravi said, we're going to do weekly series. We're going to build up from the ground. So there's no knowledge needed for machine learning in general, just an interest. This is going to be, I think, geared towards software developers, right, Ravi, that wants to pick up machine learning. Maybe they hear things about Python being thrown around a lot, right? When we talked the first time, you told me that a lot of examples out there in books, right? They are just in Python, and they're not necessarily written for the .NET community, right?
Right. That was the question that actually I was like I said that in the beginning when we read about, or whenever we search on internet about machine learning or development, what we see is like more of the things are related to Python or R or other language, nothing related to .NET developers. And I being a .NET developer for around 15-16 odd years, and like there are many .NET developers who has 7-8 years of experience or 10 years of experience. And when we say that okay, you can do anything with .NET, but we don't have enough example. And when we see ML.NET for beginners also, most of the examples are for some people who have already intermediate knowledge or basic conceptual knowledge about what is ML.NET, okay, or what is like how machine learning is being done. So our idea here would be to get the knowledge from ground up, or whatever you like, what things you need to learn in order to get ahead or get started with machine learning,
Yeah,
ML.NET,
and
especially.
super fun,
Yeah.
Ravi. I'm really excited about it as well. Can you share your kind of experience, or how did you get excited about machine learning in general? What made you interested and want to learn it?
Basically, see, I have worked on many different kind of enterprise applications, and I was pretty intrigued by like machine learning, its different utilization in the industry. The way I came to know about is by cognitive services. So I have used some example of cognitive services while I was doing Xamarin. Like I have done some Xamarin community sessions and Blazor sessions. So like in Xamarin sessions, I have written some blogs also about how to use cognitive services. So that's why my first foray into machine learning and AI. And to be very frank, I don't know much about what all these things are, but since there is a lot of buzz around this particular technology in the market and in the developer community, so I always wanted to do it. But the only challenge was like I have certain certain set of experience with .NETs and I don't want to invest too much time in learning a whole new language,
Yeah,
whether however simple it is. That's the thing that some people say that Python is very simple to learn. It's the easiest language to learn. But I said that like my thinking is that okay, it's easier to learn, but what about what I have learned till now?
exactly.
My
Yeah.
current knowledge of how can I take it forward? So that's my main end game here.
Absolutely. No, that's perfect. Awesome. So we're going to have kind of a free-form talk today, I think, and kind of get started. And the focus today is going to be just machine learning in general, AI. Talk about some terms here, kind of understand of why you want to do this, when you want to do this, and also kind of unveil some of the terminology here. And I see that Jogi, you're on the line already. That's awesome. Anyone that's currently listening into this stream, if you have any questions to me or Ravi during the talk today, just kind of put them in the chat, and we are going to kind of address and kind of pivot right together. And
Right.
what we can start off with here as well is just kind of thinking about why do you think, Ravi, that we want to get into machine learning? Why would someone want to learn machine learning as a developer?
Probably because what I have seen and what I have like read about from learned from industry people is that machine learning will be a hype, like not hype, it will be the new thing. It is the emerging thing which everybody is moving towards, and it's growing with time. So like things are machine learning is the way to go in the future, and we are in fact doing it in any way in our regular life when we are using Siri, Alexa, and all those things.
Yeah,
So we are using AI and machine learning in our day-to-day life. But so it's important for everyone. It's just like internet, that you should know how to use it or how this thing can be utilized in your particular domain or work area. So that's the main thing.
absolutely. And just to add to that as well, like I mean, I got started as a developer as well a couple of years ago and transitioned into more of this machine learning space. But I still have a foot still in development, and I don't see a reason that you have to go pick one over the other. They're going to kind of, as you said, blend together a bit. It's going to be just like knowing internet, I think, in the future. And I think just to start kind of talking about these things a bit as well, you have the data science like world that it's really data science. They're focusing on like optimizing algorithms, writing papers, doing PhDs on very intense areas. You have the software development community that is super good at software development, automation, and all those things. But in between here, we have a very nice sweet spot where I would say it's more like applied machine learning, where you can take some of those breakthroughs in the AI ML world and apply them to your applications and make them smarter. And you don't need a PhD to be in that space. You just need a fundamental understanding of what machine learning is and how you can use it for your use case and when you want to use it for use case. And I think that's also something we're going to talk about today a bit. But some of the reasons why I think people should get started with machine learning is that it's a fantastic career growth, first of all. Developers are still in sparse demand, I think. There's still fantastic number of jobs for it. But as development becomes more and more mainstream, it's important, I think, to niche yourself a bit and think about how you want to progress in your career. And I think machine learning is a great way to take that step as well. I also encourage everyone to be a catalyst on your account or on your client or your work. There are so many use cases for machine learning, and not all of them are like natural language processing or image recognition. They can be super simple, like classifiers of different sorts. And we will definitely show you during these episodes here on how you can identify low-hanging fruit at your client and start creating small models for those to solve your problem. And like that, you become a machine learning engineer, right? So that's pretty cool.
Right.
And it's fun, right, Ravi? It's fun to do machine learning. We'll see, at least.
Yeah, I would say like let me learn this thing first. Then only I can say from
Yeah.
hearing you, I can say yes, it's fun. And I have attended a couple of streams of yours earlier, and the way you do it, of course, it seems fun. Let's see how we can do it.
Cool. Awesome. Yeah. Cool. Well, I was thinking today, Ravi, should we like get started maybe doing a bit of mind map about AI ML and see how things hang together, and then talk about different terms, or how do you want to structure this?
Yeah, sure. Because yeah, mind map would be a great idea so that everybody can understand that how this thing will grow up and how they have to start with the learning. So it would be a mind map would be a great idea to get the map of whole course or whole series which we are going to do.
Sounds good. So I've been using a tool called Miro here, and it's an awesome tool for mind mapping. And kind of what I want to do today is throw out some terms here, and then see how they stick together, and then also kind of explain what things are. Like, I'm sure you heard like deep learning, or training a model, or hyperparameters, or supervised learning, and like what are those really, and how do they how are they related to each other, right? And I think a mind map is a great way to break those things down. um, and again, I encourage you all that's just tuning in now or has been tuning in for a while, that if you have any questions or if there's a term you want to know about, throw it out there. I cannot guarantee that we will know the answer directly, because data science is a very large field, but we will do our best to look it up or try to answer it the best way we can, right? We're all humans. So I started with putting AI in the middle here. And I know we're going to talk about machine learning here, but why did I put AI in the middle? Well, AI is kind of the umbrella for all these things. And machine learning is nothing more than just a pillar of AI. So we can see if we get this program to work here. We're going to put a little dot for machine learning here as well. So machine learning is a pillar of AI, right? And that's kind of easy to understand. But how does something like deep learning relate to artificial intelligence and machine learning? Ravi, do you have a guess on that?
I think all of these are part of deep machine learning, AI, and deep learning. All of this are part of single pot. That's all I can say.
Yes, good, good,
Yeah.
good, a good response there. So yeah, artificial intelligence is kind of the umbrella, and machine learning is a pillar. But under machine learning, we have actually deep learning. So deep learning is a subset of machine learning. So when you hear like deep learning, it's not this own little thing. It's actually a subset of machine learning. And we'll dive into what that means later. But you can think of deep learning as being machine learning on steroids. So machine learning is like things that has been around for a very long time, and deep learning is something that we have started doing for quite a while as well, like probably like 60 years. But it didn't take off until 2010, 2012, when we solved some fundamental issues we have with deep learning. And that's a really interesting story, and we should definitely dive into that. But I don't want to go too far in the depths directly here, so we can kind of go from there first. But what about types of machine learning, Ravi? Types of ML. I think it's just like we have different languages, right, for software engineering. We have, we have an API for web applications. We have Xamarin for cross-platform applications. The same way we have types of machine learning for different things you want to solve, right? Does that make sense? So
Yeah. I think is it something related to regression or classification, or is it something related to that?
Yes, yep, exactly, yeah. So it's we have one layer between those ones. So regression and supervised learning and regression and classifiers are called ML tasks, so machine learning tasks. And then we have like the types of machine learning fall into two different categories. There are more, but let's talk about two first here. So I'm sure you heard the term, or may have heard the term, supervised learning. So let's put that here. And we have something called, of course, the counter, which is unsupervised learning. So have you heard those terms before, Ravi?
I
Complete.
have heard about this in in one of you like in one of the podcast.
Uh huh.
Frank Kruger was explaining about this supervised learning and unsupervised learning and reinforced learning and
Yeah.
something like so those things I heard, but of course didn't knew much about it.
Awesome. Yeah, that's definitely true. And so we have. So you mentioned a couple of other types of ML as well that I think we'll skip right now, but
Mhm.
reinforcement learning
Mhm.
is one, and semi-supervised learning is another, and there's some other ones as well. But in general, when we talk
Mhm.
about machine learning for like applied machine learning or something that you would do with ML.net, they usually fall into two buckets: supervised or unsupervised learning. And the supervised learning
Okay.
is we are helping the model learn. So I've already mentioned some versions of supervised learning, and I think it's always better with examples. So we'll build that out first, and we'll go back to what the difference is here. But you said regression, right?
Mhm. Mhm.
So regression is a good example of supervised learning. We also have something called binary classifier, and that's also an example of supervised learning. Let's see. And the last one I want to mention, there's more here, but I want to mention just a couple, is multi-class classification. So what is it that makes this supervised learning? Let's have an example of like binary classification. Do you feel like, so binary of course it means that we have two choices and we're trying to predict one of two choices, right?
Mhm.
So do you have an example
Mhm.
of that, Ravi?
Maybe we can go with like we have the history data of in this particular kind of like choosing from different values, like whether they are true or false. Like we can say that identifying between no, sorry, that would be probably image classification. So yeah, we can go with like either a credit card can be valid credit card number or invalid credit card number, something like that.
Yeah, that's a great one. So that's a good one, for example. Or we have like spam detection is a good one as well. So you want
Okay.
to kind of classify something in two buckets. That's binary classification. And when you want to classify something in
Okay.
multiple buckets, it's called multi-class classification. So you see those
Mm-hmm.
things like image classification. That's a good one, for example. You want to detect if it's a flower or if it's a bird. That's different because each of those is a class. And the same thing with like different sentiments
Mm-hmm.
as well. Uh, so Yogi
Okay.
has a question here. Do types of machine learning come under AI or ML? So they come under ML, I would say. We can definitely draw another arrow here. That's a good point, Yogi. I think you're actually correct. We should just put it here instead. Good to be exact. I like it. So
Right.
all of these things here, like regression as well. Regression, we're trying to predict a house price or a stock value or something like that. But the thing they all have in common is that we know the answer. Okay, so when we train a model for that scenario, the data that we're training the model on, for example, let's take a simple thing as a spam filter. Super simple. The spam filter is going to be trained on
Mm-hmm.
probably like thousands and thousands of emails, and each of those emails is going to have a label or an answer. It's going to say is spam or is not spam. Does that make sense, right? So
Right.
when we train the model, the machine learning algorithm is going to go through each text of those 1,000 samples, and it's going to try to correlate. The text to yes or no, if it's spam or not. So it's going to say, okay, all of these are spam usually, so I know that, and all of these are not spam. So when it sees something new, it has something to learn from. So that's why it's called supervised learning, because we have something called a label. And that's
Mm-hmm.
something we should talk about as well. We should add something up here called terminology. Terminology. Because there's a lot of these terms being thrown around, right? And we should try to specify what they mean, because they're usually very simple. It's just have a different name for what you're used to. Exactly, Yogi. Yeah, spam and ham. And we'll definitely think about natural language processing as well here. So we talked about labels. So a label again is just answer. So the label is what we're trying to predict when we talk about machine learning. It could be spam or ham in this example, or it could be the house price or something else. But when it comes to supervised learning, we have labels. That's the important distinction.
Mm-hmm.
When we talk about unsupervised learning, what do you think we usually do then? If we don't have labels?
Probably let the data speak for itself.
Yeah, exactly. So do you have an example of something like that that you would think of?
No, I'm sorry, I don't have anything on the top of
That's
my
why
head.
we're here. So clustering is a good one, right? So clustering. So
Okay.
what is clustering?
Mm-hmm.
See. So think about clustering as you have different, you have a customer database, or you have something special, and you want to figure out how they are related to each other. Maybe you want to plot it in a 3D-dimensional space. We have clusters of these clients usually buy this product, and these clients buy this product, and so forth, right? But you don't know exactly. You don't know exactly what's common to them, so you can't put a label on this group because you don't know how they're related. You just know they are related. Does that make sense?
Mm-hmm.
So clustering is a way of like,
Yeah, right.
we only have the data, but we have no labels, we have no answer, but we're trying to group them in a space.
Mm-hmm.
So clustering is one way of doing that. Another way of unsupervised learning here is something called principal component analysis. Have you heard that term before?
No, it was there. No,
Yeah, it's fine. Yeah, so principal component analysis is also like a really cool term. It's also like a clustering technology, more or less. So everything, you think of like maybe we have a data set with 1,000 columns. That's a very wide data set, right? 1,000 columns. What that means is that we have a data set with 1,000 dimensions. So we have a multi-dimensional data set. So now we're going get mind blown here, right? So I know we can do like 2D graphs, we can do 3D graphs, but how do you do like a 1,000D graph, right? That's not possible, right?
Right, so, that's tough.
Yeah, it's tough. So principal component analysis, what it does is breaks down those 1,000 dimensions into principal components. And usually you have 2 or 3 principal components. So it analyzes all those dimensions, and it analyzes the variance in all those dimensions, and it boils them down to 2 or 3 dimensions that are accounts for most of the variance. So you can see these things in a smaller dimensional space, which is really cool, I think. So that's kind of what that is. And the last one I want to mention for unsupervised learning is something that is very common and it's getting very popular right now, and that's anomaly detection. Anomaly. I can never spell that correctly.
Okay, yeah, that we have heard at many places. Like people are saying that we are using an anomaly detection to detect the anomalies in this particular type of data and all those things.
Can you think of any good examples you would use anomaly detection for in your work today? Or anyone on the line?
Yeah, someone can say like in our case, like I think it's done on the case of behaviors or habits, like what kind of people like habits, regular habits people are doing, and then detecting out anomalies in that okay, if somebody is going to gym daily, but on those particular days, on some days he is not going to gym, and then like they will detect that what all the other scenarios around that why he's not going to gym. So those kind of data you can say.
Yeah, exactly. Yeah, and other things as well that for anomalies are like industrial applications. So maybe you have an industry where you produce pharmaceuticals or food or something, right? And you want to detect an anomaly in your sensors to make sure that you don't ruin the process or something like that. Or maybe you want to detect like anomalies in Bitcoin prices if you're buying those kind of things. It's very versatile, super useful, and it's really cool. Like for ML.net, for example, how we can easily create those kind of detectors. So that's really cool.
Okay.
So that's what
Okay.
supervised unsupervised learning is really. So do you want to dive into some terminology, like different? I think we all hear like different terms, right, being thrown around every day, and there's some that make sense and some that doesn't make sense right now. Is there anything specific that you've heard, or someone on the stream right now that they would like to kind of get explained to the best of my knowledge, I guess?
So I think you have explained these terminologies types of ML, supervised learning, unsupervised learning, regression, binary classification, multi-class classification, clustering, PCA, anomaly detection, and all. How should we get started with this? Basically, that's the thing. Okay, these are the terms.
Yeah.
Let's say after this session, or like from basic, how should we get start with this thing?
Perfect.
If we have to do it.
Good question. So let's talk about that a bit. So the first thing we need to do is think of the data. So whenever you start with machine learning, you need to start with the data, because without data, you can't do anything. And all the algorithms and all the ML tasks, I'm just telling you that for understanding when to use what and how to use it. We don't necessarily need to go into all the algorithms so much, especially not when it comes to applied machine learning. We can, because it's kind of fun, but we don't have to. But the crucial part is the data, and I want to put a little box here for that, because that's where we're going to start, I think. So the first thing we want to do when we start building these things and learning about these things is finding good data. So let's talk about that a bit. Where do we find good data? I will show you some sources that I have for finding good data. So what I'm doing right now is I'm sharing a homepage called Kaggle.com. So Kaggle.com, have you heard about that before? I didn't hear about it before.
Yeah, I haven't but yes, remember I told you I shared one video with you once in the beginning where somebody has shared his plan. So he said that you can get data from Kaggle.com and some other sites also. He has Hacker something or some other sites he mentioned.
Exactly.
So I think is it?
Yeah. So Kaggle is like a data science competition platform, and they have tons of open data for you to use. So when you find data, there's two ways you can find data. You can find data within your organization, which is much harder than you think it is, because it's usually in a very bad shape and it's difficult to get. But what I suggest to do is start with data sets that are open sourced and fairly clean already, and you can kind of get started quickly. Because you need data to be able to train a model on. And this Kaggle here is great for finding data. So for example, one of the ones that I just looked at the other week here is the fake and real new data set here. Yeah. And this one here, what you can download here is you can download a CSV file for the fake data, and the fake data is going to have an article name and everything, and then you have a different file for the real data. So you have that binary classifier again, right? We're talking about either it's good or it's fake news. So that's a classification issue. So this is a great way where you can find the data and you can get started. I think what we want to do, because it's pretty common, we can definitely look at datasets later. But the Titanic dataset is one of those like Hello World's datasets, because the Titanic, of course, it sank many hundred years ago, and there's a lot of data about who was on the ship and who survived and so forth. And it's fairly small, so it's quick to download. So if I'm looking here, for example, the columns it has is like, did a passenger survive or not, or did it not? The passenger class, and it has all of this data about each passenger. So it's a very good set to start creating a binary classifier, to just understand the basics, understand how I work with data, and what we do. So I think that's a great way to start for us later, I think.
Okay.
And hi Kinodem, I'm hoping you have a good weekend as well. I saw your message on the chat earlier. And again, if you have any questions or anything you want to pivot, let us know. So what I wanted to say here, when you have the data, Ravi, so what we want to do, like if we're going to start, let's say we pick that data set. We're going to go with Titanic. what is the next step, for like how to work with that and create a model? Do you have any thoughts on that?
Since we are using the data from Kaggle, we are assuming that the data is what's the step called? I think cleaned.
Yeah,
So is the data cleaned or like?
partially.
Okay, so if the data.
It's partially clean, but not all the way always. But that's exactly what I was looking for.
Okay.
It was a great answer. So once we have our data, we need to clean the data, right? So one of the things, some of the things we need to do, right, is removing empty values or outliers. We need to transform text values to numeric values, and something like ML.NET has fantastic support for that. So, like for example, why do you think you don't want to just use text values in an algorithm?
Because text, basically text comparison and text calculation is kind of memory heavy stuff.
Yeah, kind of. Yeah. So the reason we want to do that is because most of the algorithms here they don't really handle data well, or like text data. So what we want to do here is transform the text data to float vectors. So we want to have them in vectors in space. So we want to kind of label everything into a number. And I'm just telling you this because this is kind of what's happening under the hood. We don't need to know about this. This is the awesome part of like doing applied machine learning. There's going to be a method called featureized text, and that's all. We pass in the text, and out comes a float vector, and we're all good, And that's the awesome thing with these libraries, that they abstract away a lot of these things here. So it's really cool, I think, with those things. But transform.
Yogi is saying something related to dimensionally reduction in
unsupervised learning. Yes, exactly.
Unsupervised learning.
So dimensional reduction, Yogi, that was the PCA portion here, and the clustering portion. We don't need to do that when we go to like supervised learning. But when we go to things like this, we do want to do dimensional reduction for sure. I hope that makes sense. Good question. So we need to transform the data, and I'm kind of building out the life cycle now, actually. I'm going to actually add a box here. So what we're talking about right now is the machine learning life cycle. This was a great topic to talk about, Ravi, because this is going to kind of tell us on how to get started here. I'm going to pull a little thing here. I'm going to pull all these down a bit. So, because it's good to understand of like how we build a model, because that's what we're talking about right now. How do you build a model? So we talked about getting the data, we talked about cleaning the data, and we talked about transforming the data. And that's the first few steps to getting a good model. After that, what we want to do is split the data into a training set and a test set. So split the data. So why are we doing that? Why are we splitting the data? Any guesses? So it's not ETL, Yogi. ETL is for extract, transform, and load, I think, for loading data into data warehouse, something like that. When we split the data, go ahead, Ravi. Have a guess.
So basically, this Alex, to add to you, ETL is basically a different process. It is primarily used for transformation or like moving data from one source to another. Like in some scenarios, let's say we are developing some other application and we have added something to that, and we want to we have got a new client and we want to move that the data of that client from one server, one database, one type of database to another database. So that is basically ETL. We usually do it in case of there is ETL services in all the databases. Primarily what I have heard mostly is of SQL Server, because that's the one which we have used.
Exactly. And I think, Yogi, you're definitely on the right track here for the splitting the data. You're splitting it for testing. Exactly correct. And thank you for the follow earlier as well. So splitting the data, what we're doing here is we're taking our large data set, and we are putting aside about 10 or 20% of that data for testing purposes. Because right, Ravi, if you train a machine learning model, if we don't know how good it is, it doesn't do us any good. There are cases where you don't really care, but please care. It's good to care. Just like you build software and you want to have unit tests and you want to do quality code, you also want to do quality models. So you need to know how good they are, and you split the data so you have something to test it. Because you don't want to test the model on something the model has already seen, because algorithms are very smart. They're going to try to fit the model to your data, and so if you have your test data in the training, it's going to try to fit that. It's going to memorize that data. So it's not going to give you a good indication if it's good or not. If that makes sense. So yeah, so we split it, and again, like the frameworks we're going to use here has built-in methods for this. So it's going to be one method call saying split the data. Super simple and nothing special there. Cool, yeah. So once we have split the data, now we get into some of the more machine learning stuff here, and that is picking an algorithm here. So I'll just do like a ML task here instead. So once we have split the data, we have to figure out, okay, what are we doing here? And that's always good to know, right? You always want to know what you're trying to achieve. Otherwise, it's difficult. But for example, in our case, we are going to do maybe a classifier, so binary classifier. So under binary classifier, under each of these, and I'm going to add just a couple boxes here, just so we kind of get some examples here. We have algorithms. And this is where we start getting deep into like machine learning. So we have like linear regression here, for example, is a good one. We have support vector machines here, and there's some other examples here as well for these kind of things here. I'm not going to add any more of these, but logistic regression, that's what I wanted to say. Logistic regression, once again. Logistic regression. My point here is that there are a lot of different algorithms you can choose from, and each of them are like in a bucket of ML tasks. So once you decide for binary classifier, you have a limited number of algorithms to choose from. If you choose multi-class classification, you have a different bucket. And if you choose regression, you have a different bucket. So each of these ML tasks, they have different buckets of algorithms. So do you need to know which they are and what they do? You need to know kind of which ones to choose from, not always what they do, if that makes sense. And I will talk about that a bit later. But when you use something like ML.net, what will happen is that you say, okay, I want to do binary classification. And that's pretty easy to understand, right? We know we want to predict one or two values, so after a few tries, we know that binary classification is what we want to do here. And when we pick that, we then have a limit selection of maybe 5 or 10 algorithms for this task. So how do you know which one to pick? Do you have any thoughts on that, Ravi?
Probably, I think we have some data, so we will check from the data itself.
Yeah, we could try that as well, and we could definitely read up on documentation online as well, right? And see what you do and what you're good at. But what I suggest you do is try one. Try one, pick one, and then try again. Because when you do this more and more, you will kind of see how they behave on different data sets. And any data scientist today in the real world, they don't necessarily just do like, oh, this is this example. Okay, we're definitely doing logistic regression on this one. Like, they have a hunch. The more experience they get, the more likely they will pick the right one directly. But they always try multiple, and they always evaluate multiple algorithms before they pick the one that works best for your model. So it's a trial and error thing for sure. There are cases where you have there are cases when you know that one is going to be better than the other. Like, for example, if we have something called highly unbalanced data, so that means that we have binary classification, for example, but we only have 1% fake news, and we have 99% real news, right? That's our training data. If we have that unbalance in the data, where we have so much real news and only some fake news, the model is going to be biased towards real news. Because if it guesses real news, it's going to be right 99% of the time. And accuracy is not very important then, because we don't really want it to always guess real news, because we don't need machine learning to just guess real news all the time. We wanted to catch the fake news. But in an example of that where we have unbiased data, something like decision trees are known to be very good at handling that, to make sure we still find the false data, if that makes sense. So I was diving into some details here, and I don't want to kind of throw people off there, but just kind of know that trial and error is good. Some algorithms are better at some types of data and scenarios than others, but the way you find that algorithm is by trying. Just try. Don't be scared of trying. It doesn't cost much.
Okay.
Does it make sense?
So how to... Yeah, of course it does make sense. So since we are getting started, so in ML lifecycle, first we have to identify the data. For data, you have said that we can go to Kaggle, and from Kaggle we can get some sample data. For example, the Titanic data is the most basic and most simple one to learn, and then we will go for cleaning the data, then transforming the data, and then splitting the data, and then we'll select the ML tasks.
Exactly.
Okay.
Yeah.
So I think the next step would be to try it out with ML.net, or like how we can get started with this, doing this thing in Visual Studio.net.
Okay.
Or is there anything other like theoretical pending you think that we can also need to know before getting into it?
I think we're good. Do you want to start coding directly? Is that something you want to do? We can do it right now if you want to.
No, like not coding directly, probably how we can, what all things we need to know, like before coding, what all things do we need to know? If we are going to do with ML.net, or like what further we have to take care of before starting coding.
Yes. So some of the things we still need to do is complete the ML lifecycle. So there are 2 more steps or 3 more steps to talk about, and then that completes the ML lifecycle on like how you train a model and how that kind of goes around. That makes sense. So do you want me to complete that lifecycle at least first?
Yes.
Awesome,
yes, of course.
And
let's complete the life cycle first, then probably we can go ahead with that rest of the things.
Sounds good. And Yogi, thank you for thinking I'm in Texas, but I'm on the East Coast, close to Washington D.C. Texas will be warm. All right, so let's look at this. So we're going to complete this thing here. So the thing we want to do, of course, is train a model. So we pick a model, we train it, and this is where things takes time. I'm not going to talk too much about this, but just know that's a step we're doing here. And one thing I was mentioning before that is super important and that we don't want to overlook here is evaluate the model. So we need to understand on how good is this model, and what kind of data do we have. And I think this is a good talk for another episode on like what kind of metrics we have here. But the most common one, of course, is accuracy, right? Yes, Yogi, I'm in Arlington, but Virginia. Arlington, Virginia. So Ravi, so when we evaluate things, we get things like accuracy, right? But we also get other things like F1 score, precision, recall, and there's a lot of terms thrown around here, and I don't want to start talking them right now, but the accuracy is the most common one, and let's just think about that for now, saying that it's 99% accurate, and that's a good model, right?
Okay.
So once we have that, once we evaluate it and we say this is a great model, what we need to do then is to save the model. Because we need to be able to use it, right? If you don't have the model saved and can't use it, then it's kind of pointless.
Agreed.
So in Python, just to draw some parallels here in case anyone has done this in Python, in something like scikit-learn, which is a counterpart, I guess, for ML.net, it ends up being something called a pickle file, PKL file. And a pickle file can then be loaded into a Flask API, and you can kind of do predictions on that. In ML.net, the model ends up being a zip file. So it's a zip file that contains all the information about the model, and we can then load a zip file into memory, into your web API, into your Docker container, into your desktop application, or whatever you want to use there. So just think about that. That's the end goal.
Okay, so that zip file as large as data, like if when we talk about like data manipulation for ML, is that zip file as large as data, or like is it just a smaller format of data?
That's a great
It
question.
just contain the schema on.
Great question, Ravi. So it's actually small. Let's look at one. Do you want to look at one, Sifa?
Mhm.
Do you want to see what it contains?
Yeah,
Let's do it. It's a
yeah.
great
For
question.
now, yeah, we can.
I have one actually on Drive here. Let me just open it up, and then I will put it on my screen here so you all can see.
Mhm.
MLNet Jupyter. 1 second here. So we can definitely look at the schema here. Source. Alright, I'm going to drag this over so you can see. So I have a couple of models here. So for example, we have a sentiment classifier here in a different GitHub project I have open here. And this is a zip file. And I went into the zip file right now. And you can see there's different folders here. And you were absolutely correct here, Ravi, that we have the schema of the file here. And that means that we have the schema of the input data and the output data. So we need to be able to have we need to tell the model, okay, you can expect me to send in an email, for example, and I also want to, the output I want to know is if it's spam or not spam. That's the schema, right? And it also contains information about transformer chains, and we don't need to go into detail there. But think of that as the information of how do we transform the text to numbers, for example. And it also contains information about the trainer, so like the version. I actually haven't looked at these in a while. Let's look at them. It's kind of fun. You don't need to look at this in general, but it contains different things here for the master code, and I'm sure it kind of points to what kind of ML task we're using, and algorithm, and package version, and those kind of things here. So, some fun stuff for sure. Have I scared you away already?
Little bit.
Okay, I'm sorry. It's actually
it's okay.
It's a lot to take in. I was when I started doing this about a year ago or more, I was completely overwhelmed, and that is it's just normal. It's a lot of new terms, and I think examples is important, and it's good when you get hands-on experience, and I want us to get that in the next few episodes for sure, to make sure you can try it yourself, and I will guide you through this, and you will build different models, explore data, do different things, to make sure you get some like hands-on experience with this, and everyone on the line as well gets that as well.
Sure.
So we can either jump into a very easy example if you want to, or we can kind of keep building out this mind map.
So is this ML lifecycle complete? This mind map is complete?
The lifecycle is complete for sure, and there's there's tons of different other things we can talk about here. Like we can talk about terminology, we can talk about deep learning, we can talk about explanatory AI, stuff like that. Or we can leave those specific areas for when we bring it up in a different episode. For example, we can do a deep learning episode and talk about that then.
Yeah, I think we can leave that like those things deep for their particular episodes. My question after this would be like, now how we can before getting into code, how we can get started with it, like what all tools do we need in terms of IDE, in terms of like other softwares or other packages, or what all things do we need if we have to do it in on Mac or on Windows?
Great question.
Those kind of things.
So let's look at that. Great question. So you will need Visual Studio. You can also use Visual Studio Code. Code is completely fine. It's also going to work. Let me open Studio for you. Here we go. So when it comes to tools, ML.NET, which is the library we're going to use, it runs on .NET Core, which means you can run it on Windows or Linux or a Mac as well if you want to do that. And you can run it on Visual Studio Code or Visual Studio. But the best way to get started is just to open up Visual Studio like this, what I'm doing right now, and create a new project. Okay? And we're just going to show you the basics here. And when you train a machine learning model in .NET, the way you do that...
Sorry to interrupt, Alex, in
Yeah, go
between.
for it.
So, like while installing Visual Studio, do I need to select any particular package when I have to install ML.NET,
So yeah,
like
great question.
capabilities in Visual Studio?
So the only thing you need is the .NET Core workload, and I think it's in the bottom right corner of
Okay,
the workloads, and that's the only thing you need. The ML.NET
okay,
package is a NuGet package, so it's going to be delivered as a NuGet package. So
okay,
it's just a dependency, just like anything else in the .NET Core
okay.
applications. Make sense?
Okay. So we don't need, like, it's not part of the Visual Studio package. It would be kind of a NuGet package.
Exactly, yeah. So you just need the .NET Core SDK, or you can also do it in .NET Framework if you like. So the .NET
Mm-hmm.
ML.NET is compiled against .NET Core and .NET Standard. So if you want to use it in your
Okay.
legacy framework apps, that's completely works as well. Or if you want to use it in your
Mm.
new and shiny .NET Core apps, that's also preferred.
Mm. So, like other applications, do we have any project templates also for ML.NET, or like we just have to go with .NET Console app?
We don't have any templates, but there's something called the model
Mm-hmm.
builder. So that's something I use when I get started. The model builder is an
Mm-hmm.
extension, and I think it's actually built into Studio now from the last version, which allows you to just
Mm-hmm.
feed it data and gives you a boilerplate,
Mm-hmm.
exactly, boilerplate code. That's a good way of putting it, Jogi.
Mm-hmm.
Boilerplate code on the machine learning model. It gives you a model and everything else. And I thought what we can do now
Mm-hmm.
is to try that and get some like boilerplate code. So that's a good way to like,
Mm-hmm.
without knowing anything about how to build models, you'll get like a template more or less for your model directly.
Okay.
Cool. So in either case, what you would do is creating a console application for the .NET Core, and you can do F# as well if you wanted to.
Okay.
So we can call this my first ML.NET
Let
app.
let's stick to C sharp only.
Yeah. Yep.
We are all.
Yes, completely fine. My knowledge for F# is limited. I do follow Luis' stream here on Twitch. He's very good at F# and does does data tooling, I think, in the net. So you should definitely follow his stream if you want to learn more about that. And if you if you like what you're seeing today so far, definitely follow me or Ravi on Twitch. And like that, you get notified when either of us are
Yeah,
live.
folks. I won't be. Yeah, I won't be like speaking much about ML.NET in my streams. I have started one challenge for myself, that is like 15-day live streaming challenge. So it is from yesterday I started it. Yesterday was a bust. Today is this session I'm doing. I'm counting this session as one of my 15 days channel, and tomorrow I'll be back again on my channel, that is at Techie Rathor, and there I'll be talking about, in my Twitch channel I primarily talk about web development using Blazor. So right now I'm developing one like simple expense tracking application using Blazor end to end. So and we are still into the first step of finalizing the UI framework to use for developing a web application. Probably once that is ready, we can use that same UI for doing our ML.NET development also, once I'm done with this thing and I understand that what is ML.NET, and then we can continue.
Awesome. Yeah, you'll be a superstar in no time, Ravi. Cool.
Yeah, I'm looking forward to it. Thank you.
All right, so we have a simple console app here, right? And
Mm-hmm.
I'm going to show you just before I do the AutoML stuff, I want to show you how you install ML.NET and how you work with that dependency, if that makes sense. I think that's the best way to kind of get started.
Mm-hmm.
But if you want to start with ML.NET,
Yeah.
you right click on the project, and just like you do any other NuGet package, you just do manage NuGet packages,
Mm-hmm.
and you go into this here.
Mm-hmm.
And what the library is called is going to be Microsoft.ml. That's the main library. So you see you have tons of libraries here. And I don't want pre-releases because that's going to be too many. But you see that the one you want to start with is the main library called Microsoft.ml. That's like where you have the core functionality and everything to get started. And then you have a lot of these
Mm-hmm.
peripheral libraries here for specific things. So if
Mm-hmm.
you want like
Mm-hmm.
fast tree algorithms, and so the fast tree is a
Mm-hmm.
type of decision tree. but you will know when you want this. But if you want that, you will find FastTree in this library. If you want light GBM, which is also an algorithm, you'll find it here. And if you start working with something like TensorFlow, which we'll talk about in a future episode, which has to do with deep learning and this is Google's flagship, right? You have to have this library. So ML.net under the surface uses TensorFlow for deep learning. So they're not trying to build their own deep learning neural networks. We actually use TensorFlow under the surface, which is, I think, it's really, really cool and awesome.
Okay.
So you can, if you want to, one day just kind of go through these libraries and let's look at what you have here. There's some really cool ones here, like extensions is used for like deploying API models. We have vision for computer vision purposes, and we have DNNs for deep neural networks. So there's a lot of libraries here, and what we're going to start with here is the first one, which is the Microsoft.ml library here. So we'll go ahead and install that.
Okay, and in the meantime, Yogi has messaged something related to Tailwind CSS. So what is that?
So Tailwind CSS, from what I understand, is something for Blazor, right, Yogi? Don't know if it's related to. Is it related to maybe Ravi's mention of the stream?
Oh, okay.
Maybe.
Okay, I need to check. I need to check that.
That's awesome.
I need to check that.
I saw.
Yeah, that's great.
I saw some good blog posts on that, and okay, web design framework, nice. We're learning something new.
Yeah, cool. Yeah, I think he was suggesting me that I can go with Tailwind CSS to design web Blazor application. So yeah, Tailwind CSS is a highly customizable low-level CSS framework that gives you all the building blocks you need to build bespoke design without any annoying it says without any annoying opinionated styles you have to fight to overwrite.
Have you followed Chris Sanity? Chris Sanity is awesome as well on Blazor, and he has some good blog posts on Tailwind CSS. That's why I know it, because I follow him on Twitter and I've seen his posts sometimes.
I follow Chris Sanity. I follow at Charbonneau. I follow these guys, and like even I use a couple of libraries by Chris Sanity. He has like Blazor local storage, so that's the one which I'm using in many of my applications.
Okay.
And then there is one Blazor menu is also there, I think. So that I'm using in some customized way. So
cool.
Yeah, I have used him.
All right. So let's look at some structure here. Let's look at structure. So we have installed ML.net here. So we talked about the lifecycle, and I talked about the lifecycle because it's so important, because that's how you have to think when you do these things here. So what we do here, if you look at the lifecycle, the first thing we want to do was loading the data, right?
Right.
So what was the next thing we wanted to do, Ravi?
So probably we can get the Titanic data from Kaggle and load it in this.
Exactly, yeah.
Or cleaning that thing. Yeah, first load and then clean, of course. Yeah.
Exactly, yeah. And actually, I was misspoken there. So what I would do after loading is actually splitting the data first into different portions. But then what I will do is something called transform, and this part here includes cleaning, transforming, those kind of stuff here, making sure the data is in a good shape and form in general for our algorithm. And after we've done that, what we want to do then is training. So we want to fit the model. So we want to pick an ML task, we want to pick an algorithm, and we want to train the data against that model. What came after training?
Okay.
What was the step after that? Or anyone on the stream as well, feel free to chime in here.
Yeah, sure. And anyway, Alex, I think you will be sharing that mind map, like screenshot of that mind map later on.
Yeah, happy to, for sure. It's a good one.
Yeah, thank you.
So the one
of course.
The one after here is evaluate. So you want to evaluate the model.
Yeah.
And then you want to save it, right? So those are like the general steps. And I talk about these because if you look at an example of ML.net, or if you look at an AutoML part, this is how it's structured. So if you try to learn this structure, it's going to be so much easier to understand and the code, what it's doing, and those kind of things here. So everything you do is going to follow this same flow, very repetitive.
Okay.
So
Okay.
so do you wanna try to write some code here and see how far we get?
Can we? I would suggest, like, let's put a break on this thing.
Yeah.
I think we are quite overwhelmed by this thing for now.
Yeah.
So we have like initial things how to get started. Probably by next week we'll have some questions, and we'll see about this thing. And I think as a homework, what we can do is, like, for me and for other people who are in the stream, as a homework, what we can do is, like, we can follow along with this. We can also see there is one channel line series on ML 101.
Okay.
So Alex, what's your suggestion? Like, will it be helpful for us to if we see that and see that whether the code is like we are able to do follow that thing or not?
It could be helpful. I think what I would like to do in the next stream is you taking the reins here, and I am just sitting back, and I would like to see you build a binary classifier for Titanic, with some help, of course, from me if you want to. And I would like to, I would challenge you to look at this dataset here that is on Kaggle, and think about how you would do this. And if you want examples, there are examples on my GitHub page, and there are examples elsewhere as well for this specific dataset. But I think that would be a good way to start next one, and like kind of together we walk through this dataset and we try to build a classifier together from the basics, and we can hear your questions and we can see what you're thinking and what is challenging. Does that make sense to you, or do you want to do something else?
Yeah, we can try. Yeah, I can try that. Okay, I can try that.
I know. I'm throwing you into the fire here. I completely aware that this is a very tough thing to throw you into, Ravi, the first thing. But the reason why I'm doing it is because the only way to learn machine learning and do this is to get your hands dirty and just start. It's going to be tough, I promise you. It's going to probably not make any sense in the beginning, but that's okay. That's why we're doing it together, and we're going to try to learn together, and I'll promise you I will guide you through this as well.
Okay, sure.
Sure.
And another thing, Alex, I would like to know, like, if what's your suggestion that how much time someone, if he is willing to learn ML.NET with us, should give daily for ML.NET? It's like in hidden words, I'm asking you that how much time should I give apart from like my day-to-day routine for this thing?
Great question. So I would suggest half an hour to an hour per day if possible. I think that's a good way to start.
Okay.
What I would start, and I encourage everyone online here as well, is to go into this repo right here. It is github.com/machine learning-samples. This is the community sample for all of ML.NET, and the community, everyone in the community has contributed to these samples here. So you see, for example, different examples of binary classification and multi-classification, and each of these has a repo under them. So, for example, let's take something like spam detection. You can go in here and you can understand, okay, this is the life cycle we're trying to do, right? We talked about that before: build, train, evaluate. And this is the code that is used for that specific data set and how to evaluate it and so forth. So this is a great way to get started, and I would just encourage you all to go into this repo, look at some examples, and like think of, okay, what does this mean? What is this thing here? And next episode we'll dive into talk about these more in detail. Like, for example, what is an ML context? We can talk about that next time. But at least if you have had a look at it, you can at least kind of get familiar with those terms and terminologies.
Sure.
That's a good one.
We'll
but I think don't spend too much time per day, because it's easy to get overwhelmed. One of the things I've learned, helps me to learn, and we're all different, is to just do bit by bit and let your brain digest it a bit and think about it. Okay, what does this mean really? And the next day you take it up again and okay, I understand what this means now. If that helps. Anyone also in the stream, I picked 2 books that I have read as well. I don't recommend maybe everyone to buy them and read them, but I've liked them. They are both for Python, so they're not going to be maybe useful for us. But especially, let's see, they are very good for like basic machine learning understanding. So the one I would recommend mostly is this Deep Learning with Python by François Chollet. And you should definitely follow François on Twitter. So he's I think the founder of Keras, actually, if I'm not mistaken. Let's see here. But he's a fantastic author. This book is really good, and the first chapter here is like it's going through the basics of machine learning and deep learning without too much Python stuff. And then after a while, it transitions to Python and examples. So, and the same thing here as well, hands-on machine learning with scikit-learn and TensorFlow. It's also Python geared, and I know that's not what we want to achieve here. But the first chapters or so are like agnostic of which background you come from. They're more about what machine learning is and kind of things we talked about today. So it's a good foundation to start with.
So one you said deep learning with Python, and another one, what was the name of the second one?
The second one was hands-on machine learning with scikit-learn and TensorFlow. And actually, let me bring up Amazon here if you want to for that, and you can do this hands-on machine learning. So this is the first one that I can recommend. It's good, useful. I like it. I like reading it a lot. It's definitely like a very heavy one, but you can definitely start on the first 2 chapters. The second one is Deep Learning with Python. Enter Manning.
So both of the first 2 chapters of the both of these books will be like the basic stuff without the Python things.
There's I think there is actually a new book that is called Machine Learning.net that I haven't read yet by I can't remember his name right now. Let's see. Interesting. Mastering machine learning. I have to find it, but there was a book just released. You can probably search for it as well. It's called something Machine Learning in .net, and it was by.
No, I think.
Go ahead.
There are a couple of books on machine learning. Challenges like those are on the .net things around .net. Let me see. I have a couple of things.
Yeah. But I like books are good if you want to read. What I suggest is going to something called Towards Data Science. Towards Data Science is like Medium for data science, and this is a great blog site for different articles. So I usually follow this one, and I kind of tune in and read, and they have some great articles about some basic stuff as well as something more advanced. So if you want to like read about what are neural networks, they have some great articles here on those things. They also have good examples of applied machine learning. So definitely, I think this is like the medium version of data science, and I recommend you all kind of have a look at that as well. I like it.
Okay.
Yeah.
Okay. Thanks, Alex. I think that's pretty much. That was very informative session for us about machine learning, deep learning. Thanks a lot for taking out time for me and all the people on the stream. We'll continue this series, and let's see whether I'm able to do what you have said to do. You have asked me to do next week. I'll of course, but I'll start. Of course, I'll start. I'll give at least. I'll honestly give at least 1 hour daily.
Yeah. Awesome.
To this thing, and let's see how much progress I have done.
Ravi, I believe in you, and I believe in everyone on the stream. Please follow along as well and continue kind of working with this if you want to. We want to teach all of you about machinelearning.net, so definitely kind of have it a go, and we will kind of support you and help you the best way we can. One thing I also want to mention before we finish here is that if you want to learn more about machinelearning.net, The conference that me and John Wood are organizing is only 12 days away. And as of this morning, we now have our speakers. So we have our speakers selected and our sessions up. And there's going to be quite a few awesome talks here, really. We're going to have, you can go on schedule here. We're going to have a machine learning workshop the first day for 4 hours. It's going to be by Bree Ackman, who is the program manager at Microsoft for this library. And that's going to go through really the basics from the start. Like it's going to be great for anyone viewing this stream, I think, to kind of follow along here. It will talk about the basics of machine learning. It will talk about how you start your first model and so forth. So if you like what you're seeing so far here, I'd recommend you registering for this one here.
Sure, we'll definitely do. So is it paid or is it free?
It's completely free. It's a free workshop, a free conference, and you see here we have some intro talks here, and we have some more advanced talks on different topics here. But it's completely free.
Okay.
And the way I recommend you, recommend you register here. There's a register button here. When you register, you will just have to sign up with your name and email, so we know who to contact. And we're going to send more information next week on how to tune in. But it's going to be live streamed on Twitch and YouTube, so you can just kind of tune in to that channel. And I will do. So it's going to be live streamed on Twitch /virtualmlnet here. This is where you're going to find it for sure. Yeah, that's kind of what I want to say about that.
Okay. Yeah, I think I am already following that thing. I think I have registered also for this training.
Yeah.
So that's why I am following this thing.
And
yeah. Thanks for sharing all these things.
Thank you very much, and thank you all for listening in. And if you like what you do we've done so far, please follow me or Ravi, and we'll see you next time. Thanks, y'all.
Yeah, sure. See you guys next week. Thank you. Bye-bye.
Bye, guys.